Let us proceed with probability theory. In this video, we will be discussing concepts such as independence of events, conditional probability, multiplication theorem, and we will do certain illustrative example problems. Let us begin with the concept of independence of events. Two events are said to be independent if the occurrence of one event, say A, does not influence the occurrence of the other event, say B. Let us imagine about an examination. If two students are writing this examination independently, the marks of one student will never influence the marks of the other student. On the other hand, suppose they are writing this examination in mutual discussion, definitely the marks of one student will influence the marks of the other students. This is the concept behind independence of events. In the language of probability, it can be expressed as follows. If two events are independent, probability of A intersection B will be equal to probability of A into probability of B. Next, let us come to the concept of conditional probability. Conditional probability is nothing but probability of an event given that another event has already occurred. This means you are getting an additional information. Another event B has already occurred. In the light of that information, conditional probability calculates the probability of the first event. I will take a simple example. Just imagine about a box containing 6 white and 7 black balls. Assume white balls are numbered from 1 to 6 and black balls are numbered from 1 to 7. Suppose I am taking one ball at random from this box and ask you what is the probability that this ball is numbered 2. Clearly, using classical definition, you will answer it as 2 by 13 because here we have 2 balls numbered 2 and totally there are 13 balls. So according to classical definition, probability should be equal to number of favorable cases divided by total number of cases, which is 2 divided by 13. Now suppose I am giving you an additional information. This ball is a white ball. Under this additional information, what will be the probability that the ball is numbered 2? This probability is known as conditional probability. Now the probability will be changed. It will be only 1 by 6. What is the reason? There is only one white ball numbered 2 and there are only 6 white balls. So according to classical definition, it must be 1 divided by 6. Mathematically, it has been proved that conditional probability is given by the formula P of A given B equal to P of A intersection B divided by P of B. Multiplication theorem is actually derived from conditional probability formula. Conditional probability formula states that probability of A given B equal to probability of A intersection B divided by probability of B. If you cross multiply, you will get it as equal to P of A intersection B equal to P of A given B, that is the P of B. In a similar manner, if you are using the formula for P of B given A, you can express it as P of A intersection B equal to P of B given A into P of A. This is known as multiplication theorem. So, multiplication theorem can be stated in two different ways. Either P of A intersection B equal to P of A given B into P of B, or P of A intersection B equal to P of B given A into P of A. Next, we will discuss certain simple examples. These examples are not complicated problems, but simple problems designed to understand the concepts behind the rules studied. Our ultimate aim of the course itself is not to do complicated problems, but to understand the concepts. So I'll be using only very simple problems which can make you understand the concepts that we discussed. Let us come to the first problem. It states that probability that a woman entering a shop purchases cereal is 0.24 and she purchased pulses is 0.30. Assuming purchases are independent, find first one, probability that she does not purchase pulses. Probability that she purchases both cereals and pulses. 3. Probability that she purchases either cereals or pulses. Let us analyze this problem. So here you are given two events. The woman purchases cereal and the woman purchases pulses. Let us name it as A and B. A denote the woman purchases cereal. You are given probability of A equal to 0.24. Similarly, she purchases pulse, that is B. Probability of B is given to be 0.30. Also given A and B are independent. Now, the first problem is we have to find out probability that she does not purchases pulses. Purchase of pulse is named as B. So does not purchase pulses means complement, that is 1 minus P of B, which is given by 1 minus 0.30, that will be equal to 0.70. Next one is probability that she purchases both cereals and pulses. Both cereals and pulses means A intersection B. You are given A and B are independent. Hence, by the concept of independence, probability of A intersection B will be equal to probability of A into probability of B. That is nothing but you can simply multiply the probabilities and get the answer like this. Third one, she purchases either cereals or pulses. Either cereals or pulses. That means A union B. Probability of A union B. For that I can apply addition rule, which states that probability of A plus probability of B minus probability of A intersection B. But in this case, A intersection B will be equal to probability of A into probability of B. Now we can substitute the values and compute probabilities. I hope that this is really simple. We have illustrated three concepts: one, probability of the complement, independence of events, and how addition rule can be applied together with independence of events. Next, let us take the second example. The problem says a consulting firm is bidding for two jobs with two large multinational corporations. The company executives estimate that probability of obtaining the consulting job with the firm A, named as event A, is 0.45. The executives also feels that if the company get job with firm A, then there is a 0.90 probability that the firm B will also give the company the consulting job. What is the company's chance of getting both the job? As usual, let us analyze the problem. This firm is bidding for two jobs, one with firm A and the other with firm B. Let us name these two events as event A and event B. You are given that probability of obtaining the consulting job with the firm A, that means probability of A is given to be 0.45. Next, the company executives feels that if the company get job from A, then probability that the company get the job from B is 0.90. This means if event A happens then probability of B is given to be 0.90. That is, you are given a conditional probability. Probability of B given A. If A happens, what will be the probability of B? That is given to be 0.90. That is, probability of B given A is given to be 0.90. Now let us see what is asked. The company's chance of getting both the job. Probability of getting both the job. That means A intersection B. Probability of A intersection B. Here we can apply multiplication theorem. You are given P of A and P of B given A. Hence, multiplication theorem is to be applied in the form P of A into P of B given A. Now we can substitute the values and get the answer. Hope that the concept is clear. Let us take the third example. A bank loan officer knows that 12% of the bank's mortgage holders lose their job and default the loan in a course of 5 years. She also knows that 20% of the bank's mortgage holders lost their job during the period. Given that one of her mortgage holders just lost his job, what is the probability that he will now default the loan? Let us analyze this problem. A bank loan officer knows that 12% of the bank's mortgage holders lose their job and default loan. So two events are there. One is the mortgage holders lose job. The second one is mortgage holders default loan. Let us name the first event as A and the second event as B. So A is nothing but mortgage holders lose their job. B is they default the loan. So here you are given probability for both. Probability that mortgage holders lose their job and default the loan. That means probability of A intersection B is given to you. Now let us see what is given in the next para. She also knows that 20% of the mortgage holders lost their job. That means probability of A is given. Probability of A is 0.20. Now let us see what is asked. Given that one of the mortgage holders lost his job, that is, you are given A happened, then what is the probability that he will now default the loan? What is the probability for B? That is, given A, what is the probability for B? That is, probability of B given A. We can use the definition of conditional probability, which is nothing but P of A intersection B divided by P of A. Now we can substitute the values and get the answer. Let us go to the final example. A financial analyst believes that if interest rates decrease in a given period, then probability that stock market will go up is 0.80. The analyst further believes that interest rates have a 0.40 chance of decreasing during the period in question. Given the above information, what is the probability that the stock market will go up and interest rate will go down during the period in question? Let us analyze the problem. A financial analyst believes that if interest rate decrease in a given period, then probability that stock market will go up is 0.80. So two events are there. One is interest rate decrease. The other one is stock market go up. So let us name it as A and B. A denote interest rate decrease. B denote stock market go up. Here you are given that if interest rate decrease, then probability that stock market will go up is 0.80. That means if A happens, probability for B is given to be 0.80. That means probability of B given A is given to be 0.80. Now let us see what is the second para says. He further believed that interest rate have a 0.40 chance of decreasing. That means probability for A is given to be 0.4. Let us see what is asked. Given the above information, what is the probability that the market will go up and interest rate will go down? Probability that market will go up, B, and interest rate will go down, A. That is probability of B intersection A. Probability of B intersection A means probability of A intersection B itself. So I can apply multiplication theorem. Probability of A intersection B. Here PA is given, so I have to use it in the form PA into P of B given A. You can substitute the values and get the answer. I hope that I could explain all the basic concepts in a simple way, and we have illustrated these concepts using simple examples also. With this background, we can proceed with probability distributions that we will do in the next video. Thank you very much.